We want to test the claim that the average weight of gold that customers bring into a gold purchasing store is different from 3 ounces. You record the weight of gold brought into a store of the next 5 customers and calculate the test statistic as 3.454. Find the p-value of this test statistic. So what I want to do is figure out, first of all, is this a left tail, right tail, or two tail test? And to do that, I'll start by getting the claim in symbols. So the mean is different from, that tells me the claim is that the mean is not equal to 3 ounces. The opposite then is that the mean equals 3 ounces. Now the one with the equals always gives us our null hypothesis, and I change that to equals, although in this case it stays equals, no changing needed. Then the other one, no changes ever, mean does not equal 3, stays the same. So this not equals from the alternative hypothesis tells me this is a two-tail test. So what I do then is, I know my test statistic is positive, so I'm going to put it over here on the right side, 3.454, and I'm going to find the area to the right. Now because this is a two-tail test, I'm going to double it, assuming that that same area is over here on the left. Now with the I'm going to do this in 2 ways, one with the t-distribution table and another using technology, in our case, a spreadsheet. So with the table, the t-distribution table, I won't be able to get the exact p-value, but I'll be able to get a range, which is usually good enough when we start doing full hypothesis tests. But for this case, either case rather, we need the degrees of freedom, and that is, of course, my sample size minus 1. And so it is 5 minus 1 in this case, which will be 4. So I need to know my degrees of freedom is 4. This is a two-tail test, and my test statistic is 3.454. So let's start off finding the range in the t-distribution table. So I look for, first of all, my row, degrees of freedom, is 4, and now I'm looking for 3.454. I don't see 3.454 anywhere, except I can see that it's between these two numbers. It's bigger than 2.776, and it's less than 3.747. So that tells me that my p-value must be between 0.02 and 0.05. And I'm looking in the area in two tails because this is a two-tail test. Had this been a one-tail test, I'd say that my p-value is between 0.01 and 0.025. Now, one thing to keep in mind is, in a two-tail test, I could just as easily have come up with a negative test statistic, in which case I would have put it over on the left, but because it's a two-tail, I know there's area on the right as well. But when I come over here to look for this, so let's say my test statistic was negative 3.454, I still make it positive to compare it to these values. So no matter what my test statistic is, positive or negative, I'm going to think of the positive version when I'm comparing to these values, in which case I would have gotten the same thing. So if my test statistic had been negative 3.454, I'd be over here, but I would still be looking in the same, between the same two columns, because that's where the positive version would be, and then my area in two tails would still be between the same things. All right, what if we needed a specific p-value, not this range, like we would in this problem here, because it's asking for the specific p-value? Well, luckily we have spreadsheets that we can utilize, and so I would use the equals t dot dist. I'm always going to plug in the positive version, so even if my test statistic was negative, I'm still plugging in the positive version. Force it to be positive, because that's what this function is expecting. The degrees of freedom in our case was 4, and this is a two-tail test, so I'm going to put 2 here where it's asking for the number of tails. and that tells me my p-value is 0.02595. Let's round that up to 0.026. So my p-value 0.026, which is indeed bigger than 0.02 but less than 0.05.